Hello, welcome. In this short video, let us look at an introduction to stability of a system. First, let us look at the definition. For a stable system, if the input is bounded, that is, if the value of the input does not change too much, then the output must be, that is, the output must also be bounded. That is, it does not diverge. So, for a system that has a finite input, that is an input that is bounded, then the output is also finite. That is, it should also be bounded. That is, if the input x of t is changed to x of t plus delta x of t, where delta x of t is small, then the output resulting from the change in this input will be y of t plus delta of y of t, where this change is also small. That is, if this is small, then this is also bounded. Then this system is a stable system. That is, small changes in the value of the input only produce finite changes in the value of the output. Let us look at an intuitive example explaining the concept of a stable system. Consider a ball that is located on the top of a steep hill. That is, we have a hill and a ball. So, consider the input to be x of t, which is an acceleration in the horizontal direction, and the output to be y of t, which is the depth, that is the distance in vertical direction. So, in this type of system, small changes in x of t will lead to very large changes in y of t because of the slope of the hill. That means y of t, function of x of t, the small changes in x of t will lead to very large changes in y of t. So this system is an unstable system. Now consider a situation where we have a ball located in a valley. That is, this is a ball. Now, the input x of t is the acceleration in horizontal direction, and the output is the height that is the distance in vertical direction. Then, small changes in the value of x of t will also lead to small changes in the value of y of t. So, in order to get very large changes in y of t, x of t should also be changed by a significantly large value. Therefore, this is a stable system. Let us look at some more examples on stable and unstable systems. Consider the following input-output relation where y of t is equal to exponential of a times the input x of t. For the case where a is greater than 0, that is, this is a positive exponential, then the system output y of t can become very large for small changes in value of x of t. That means y of t can get to close to infinity for small changes in value of x of t. For example, in chain reactions and in population growth. That is, when y of t is representing the, for example, amount of mass in a chain reaction or the total population in a population growth curve, then y of t can become very large with small changes in x of t. However, when a is less than 0, small changes in x of t will lead to finite changes in y of t. That means the system is stable when a is less than 0. A good example is a passive RC circuit. Another example of a stable system is y of n is equal to 1 by 2n times k equal to minus n to n x of n minus k. This is basically an averaging filter across a window from minus n to plus n, and this system is always stable because for the value of the input x of n minus k, which is basically a delayed version of x of k, is bounded by a value alpha, then because of the system transformation, y of n is also bounded by the value alpha. Therefore, system is always a stable system. However, the system defined by y of n is equal to the sum k equal to minus infinity to n x of n minus k. This is not a stable system because it adds all the values of the input from the beginning of time to the current instant, which can potentially add infinite number of values, and therefore is an unstable system. That is, the output might diverge. That is, even if the value of x of n minus k is bounded, that is for example it is a delayed version of x of k, which is equal to the unit step function u of k. In this case, the output y of n is equal to the sum k equal to minus infinity to n u of n minus k. And u of n minus k, the value is always 1 for n greater than k. So this is equal to 1 for n greater than k. So even though the input is bounded and basically a constant for each value of k, the output can be potentially infinite because you are adding infinite number of values. So this is an unstable system. So the key difference between stable and unstable systems is that for bounded inputs, the output is also a finite value for stable systems, and the output can diverge for unstable systems. Thanks for watching.